Hi, in this question, we will try to investigate either the kinetic energy and momentum are conserved during the inelastic collision or not. So, if they are not conserved or any one of them is not conserved, then what is the reason behind it? We will prove it with the help of laws of conservation of energy and momentum as well as with the equations. So, kindly stick to the video, we will prove it. First of all, I need to show you the examples of inelastic collision. So this is one of the example, like all the example which involve embedding of something into the other. For example, if this is a bullet that is fired towards this block and it is moving with some initial velocity u, and at a very next moment it is going to embed in this block. So it will look like this when it will embed, and the moment when it will hit the block, its energy will be delivered to the block, due to which the block will not be able to stay at that point. It will move along a curved path to conserve the energy, but not the 100% of energy will be conserved. I will show you later on. So this is how it will go to its new position. So it will move like this. Anyways, let me show you another example. This scenario is also very famous in past papers, IB exams. So let's say if this card is moving with some initial velocity and it is not moving, so it have no momentum. So if their collision is inelastic, let's say the first card, upon hitting the second one, it it stick with the other one, right? So right after the collision, they both are moving as a one system. So this is also an example of inelastic collision. So for example, after the collision, right after, immediately after, so its common velocity is v. So we will investigate either momentum and kinetic energy as conserved or not. So we start with this thing that they mention categorically that there's a no external force in a question. So if there's a no external force, it means that the rate of change of momentum of system should be zero. Okay, which means that the change of momentum of system is zero. So if the change of momentum of system is zero, it means that the change of momentum of the card 1 is equals to the negative of the change of momentum of the card 2. Or in other words, dear students, you can say the sum of the change of momentums of both cards is zero. So we can only take the idea, like the only conclusion that we can draw from this one is that if the change of momentums of both cards are equal in opposite direction, or they are equal in magnitude, which means that the total momentum before the collision, if it has a mass m and both have a mass m, so what is the total momentum before the collision? That is mu. So mu is equals to the total momentum after collision. Now it's a system of masses, so it have a total mass 2m. So 2m into v. This is what it means. So what is a common velocity that we get from here? So obviously we get a conclusion that the momentum is obviously conserved, and that's why we are able to find out the common velocity, which is equals to u over 2. And if you wonder that why I have written this thing that the both changes or momentums are equal in opposite direction, just because obeying the Newton's third law, which says that the same force will be applied on both of them, but in opposite direction. When the forces are equal in magnitude and in opposite direction, then their changes of momentums will also be equal. So this is, so it means the momentum is conserved. Now let's quickly derive the result, that is the kinetic energy conserved or not. So what is the total kinetic energy before collision? So only the card 1 was moving. So initial kinetic energy is just due to the kinetic energy of this card, whereas the other card was at rest, so it have a no kinetic energy. And what about after the collision? So the kinetic energy, if the kinetic energy is conserved, then the after collision kinetic energy should be equal to this one, but you will see it is not, because after the collision the kinetic energy of the system is the sum of the masses, which is 2m, into the speed, which is u over 2. We just have seen from this equation, so we will take it squared, so it is 1 over 2 into 2m. It is equals to u square over 4, and you can take 2 over 4 outside, and inside we have 1 over 2 mu square. And what we get, interesting result, that 1 over 2 into initial kinetic energy. So it means that the final kinetic energy is reduced to just one half of initial kinetic energy, which is obviously we get a result that is not conserved during the inelastic collision. Either it's a cart collision or it's a embedding cases in which an object embeds into the another object. In all of these scenarios, kinetic energy is not conserved because energy is transformed into some other forms like sound or heat, a minor amount of heat as well. In fact, a minor amount of sound as well, and major amount of heat. So for this question from this exam, the option A is correct, which says that only momentum is conserved.